So I think at the end of the last video, I declared our arena allocator that we made to allocate memory for our Lua states as working. But in this video, I'm going to show you that actually I was wrong about that. It kind of doesn't work. It mostly works. So the thing we actually want to do, and this is going to show up the error, is we want to handle this case where we run out of memory, because our arena allocator is currently, well, in this case, just allocates 20 kilobytes of memory. But if you run out, it just asserts. And that's in here somewhere. Does it just assert when we deallocate, when we allocate? We assert that we just run out of memory and say, sorry, we can't do that because we've got a fixed pool of 20 kilobytes. And if we go over it, well, you're out of luck. So what we really want to do is handle that case, because what we can do is, what we did in the free list is we allocated a chunk of memory and we just kept clipping bits off. Whenever we needed some memory, we clipped some off. And at the end, we put any free lumps onto our free list, and we knew they were more than 64 bytes. And if we did any allocations, we could do them from there if we needed to. But what we want to do is say, well, instead of this assert, if we've run out of memory, we should just fall back to the original global allocator, which originally in Lua, it's giving you malloc and free. So we can fall back to the global allocator in that case and say, okay, we did run out of memory, but at least we can carry on working. And that may be a good thing for your allocator to do, because if you don't do that, what people will do when they use it is probably just start allocating more and more memory because they're worried that it will run out. And eventually you end up wasting tons of memory. So it'd be much better if people could say, oh, well, actually, this thing will work really well with small allocations from this little heap, and if it does go over, well, it's not going to crash, you'll be okay. So you don't have to be, steal a chunk of memory from the operating system to get it to work. So to do that, we're going to create another allocator, and it's going to be very similar to our, well, in interface, it will be very similar to our arena allocator, but it's just going to be global allocator. So I'm basically going to recreate what we've got in the arena one, which does allocate, deallocate, and free. I'm going to copy the interface. So we had allocate. What else did we have? We had a deallocate, and we had a reallocate. So copy that. So that's just building up the interface for our global allocator. So we're going to do exactly what we did in the other one, except we're just going to kind of go back to the malloc and free. But I'll seeing as this is a C++ thing, we'll use the global operator new and deletes. It's pretty much the same thing. It probably even calls the same code under the hood. I'll also copy our function that we need. This is the function signature that Lua needs to allocate memory. So I'll copy that and I'll just paste that right in. And I will, instead of making an arena allocator, I'll say it's a global allocator. So you can see from this that you could probably make a templated Lua alloc that could take in either a global allocator or arena allocator, because this down here will be the same: allocate, deallocate, and so on and so on. So this one, we'll put a little comment. Allocates from global memory. That's pretty much it. It doesn't really do, it's not going to do anything totally special, but we'll keep the same interface that we've got for the other one. So in our allocate, let's just see what did we have in the other one. We had, oh, this is doing our free list and this is doing our bytes. So we don't really need any of that. We're just going to do malloc. Think. Oh, actually, let's do the operator new. Let's do this. So that's just going to allocate from global memory. So that's really all we want. We're going to allocate from there. When we deallocate, we are going to operator delete. And that just wants the pointer. And I think, was Lua passing us null pointers for its deallocation? Yeah, it was. So we just said we couldn't do that. So let's say we can't do it here as well, just to be sure. We don't need original size anymore. I'll just comment out that parameter because, well, because in the case of operating new and delete, it knows how to delete this thing. It doesn't have any other parameters there, does it? Oh, it can take the size, but we don't actually, do we need to send it? We don't need to give it. So I think when it knows this, it's gonna work out how big it's making the block, and it's gonna store that somewhere in the memory, and then when it deallocates, it's gonna read that information and know how to deallocate the memory. So we'll try that anyway. We'll see how that works, but I think that's right. And then actually reallocate, I think, will be identical to our previous one down here, which is it calls allocate, it does a mem copy, and then it calls deallocate. So we can take that exactly as it is and just use the same thing. So we're already calling into allocate, deallocate, and mem copies being used. So that's gonna not compile. What have I done wrong there? Have I missed out on something here? Deallocate. I'm missing a brace out here or something, I think. Yeah, missing a brace. I was thinking, why is it complaining about string? So that's all good, but that doesn't do anything because we've not called that code yet. So let's see if we can use that global allocator instead. So this should be able to stand alone away from the arena allocator. We'll get rid of our memory pool. We don't need to reset the pool. We don't need that anymore. So instead of our arena allocator, we just do global allocator. Global. And we will pass it in a... I'll put it up here instead of this one. We'll pass it in the global allocator. I'll call it pool again. It doesn't have any construction parameters. In fact, it doesn't actually have any state. So it technically doesn't even need to be a struct. But as soon as it's got no state inside it, C++ optimizes these kind of things away and just turns them into function calls anyway. So that'll still work fine. We're still passing through this global allocator as a user data pointer and using that, but I think we should probably do that anyway, because if in the future we did decide to put some state or debugging in here, then we can do that. So it might be something we want to do. So that's changed. That should, let's see, compile. And this is where it goes wrong. It didn't seem to finish that. Something went wrong there. So I'll just look at that in the debugger. And let's just see what's going on there. So it crashed in deallocate. It crashed in reallocate. What was it trying to do? It was trying to load a Lua state. What was it? Where was it? Here. Oh, we were just executing our script. So I got really confused about this and I was thinking, why is it failing to deallocate? Is it a null pointer? No, it's not. And in the end, I was like, I really can't work out what's going on here. So I ended up just putting in, this is how I solved this. Did a realloc there. Because I just wanted to see what it was doing in kind of printout terms. Did a dealloc here. Oh, I need to put these on. And I did an allocation there. And I just put these printfs in because I was like, what the hell is going on? And let's just have a look. So we went alloc, alloc, alloc. That's creating our new state. And then we did a realloc and an allocation and delete. Now, the allocation and delete came from the realloc. So the realloc itself is breaking this. And then the allocation and deallocation are going wrong there. So once I found that out, I put a breakpoint in this reallocate, and we'll have a look what's going on in there. And this is where we find out the part where it wasn't working, because is it doing what it was doing last time? Yes, it is. I think you'll notice that last time when I wrote this allocation and deallocation, what I did was I said, okay, we're reallocating memory, but I was basing on the assumption that when you're allocating memory that you're allocating it because you've run out, so you always need more. But in this case, Lua isn't doing that. It's actually doing, if you look down here, where is it? Shrink. It's doing shrink stack. There it is. So it's actually allocating. It realizes it's got too much memory, and it's making it smaller. So our original size was 640 bytes, and we went down to 544 bytes. So we actually got away with this in our previous allocator. It was probably copying over some dodgy memory somewhere, but what actually happened is I allocated the new size, 544, and then I thought, well, I'll copy the original size into the new area that we've allocated, because I made the assumption it's always getting bigger. But actually, it hasn't. The original size is, the new size is 544, and the original size was 640. So I copied in 640 bytes into a 544 byte memory area, which basically is trampling over memory. And the global new and delete is able to work this out. I think it's got some little bumpers on the memory that works out you've trampled over some of this memory. And it just crashes when we do that. So that's just me being silly and making the assumption that when we reallocate, that the amount of memory was always getting bigger, but actually it was getting smaller. So we should fix that now, and we should fix it in our memory, in our arena allocator as well. Let's get rid of those. So all we really have to do is just take the minimum of those two values. It's not that difficult to fix, really. So bytes to copy. I mean, one of the other ways of doing it is actually not reallocating the memory at all, because you could just say, okay, well, let's just leave it the way it is, because I'm not going to shrink anything. So that's one way of solving it. But in our case, let's assume, I mean, it could be that this was a massive amount of memory and it needed to get deallocated to a smaller amount. So let's just for now assume what we assumed before, which is the original size. And then if the new size is smaller than the original size, or it's smaller than bytes to copy, then we'll just use the new size. So we'll still allocate the new size, we'll still deallocate the old size, but when we copy our bytes in, we just copy the smallest amount that there is. So we have to do that because, well, we need that new area to have the same stuff as before. So let's see if that works. So it looks like it does. It's not crashed. Seems to have gone through our script correctly. We should probably put the same thing in our arena allocator, because that's got the same problem. Just making that dumb assumption. That's where most bugs come from, isn't it? It's just making the assumption about how some system works when it actually doesn't work that way at all. So that was me making the assumption that we were always reallocating because we'd run out of memory, and we hadn't. So we probably did trample some memory or do something here, but we don't have any like error detection or, you know, trample debugging in our arena allocator. So it carried on working fine, but it's possible we broke something. It's possible we got away with it. It's not entirely sure. But anyway, apart from that bug that I've fixed now, that is a fully working global allocator, which just allocates from the global new and delete. So almost exactly what Lua was doing, except I've just put it into a little class. And we've called it in our, we've just used it there temporarily, but we'll probably swap out to another one. So what I'll do now is in our arena allocator, I'm going to have one of these global allocators as well. And allocator, that looks wrong. So this is going to be our fallback allocator. So we're going to use this whenever we run out of memory. And you can see that this didn't have any member variables. So this is a 0 size class. So this actually doesn't even add any space to the class, just putting this here, if you're worried about that, depending on if you were or not. So what do we need to do now? We need to, when we allocate, we're working out our size to allocate. We're checking to see if it's below the minimum block size and we have a free list head. In that case, we can take out our free list. That's still fine like before. If not, we are going to that aligns our memory to where we want it to be in our current, so that's in our current pool. And then we check to see if we've run out of memory. Now this is the bit now we can handle. So rather than making assert, if the current plus the allocated bytes is less than end, then the last time I did this, I got these backwards, didn't I? So I think we can have less than or equal to end. So that's just saying, do we have enough memory to do this allocation? And if we do, let's carry on and just allocate out of that pool. Otherwise, whoops, that's not return, is it? Neither is that. Let's just do it from our fallback allocator. Size in boots. So that's just saying, oh, instead of running out of memory now, let's fall back to the global allocator and let's make sure that we just carry on working as if we were before. So we're basically trying to get memory out of our free list and we're trying to get it out of our memory pool. But if we do happen to run out, which we kind of will with this one maybe because it does burn through memory a little bit, then we're going to go back to our global allocator. Now we've done that, we need to correctly deallocate that memory. So same thing kind of going on in here. We've got, when we go into deallocate, we do our calculation to work out how many bytes were really allocated, which is the same thing. We'll do allocated bytes, not size in bytes in there. Should we bump that up or not? I think we'll, for now, we'll just bump it up. This is the thing that bumps it up to our 64 bytes. Do we need to do that or not? Probably not. Let's leave it like that for now. Because that was bumping us up to 64 bytes because we were going to put it on the free list. But we don't need to do that with the global allocator. We can just allocate whatever we want, I think. So then when we come to deallocate, we can't deallocate null. We check the allocated bytes from the original size. Is it greater than or equal to the minimum block size? If that's the case, then we need to put it onto the free list. Otherwise, let's see. Otherwise, we're just burning through memory. So actually what we need to do here now is we need to check whether this pointer is actually in our arena pool. And if it is, we need to deallocate it with the global allocator. So we've stored the begin and end. If we look up here, we've stored the begin and end of our memory pool. So if that pointer is inside that pool, we're good to go with all of this code. So if the pointer is greater than or equal to begin, and I nearly typed and then, and the pointer is less than or equal to the end, then all this code is good to go. In fact, we don't really need that. We're just burning through memory. We'll just get rid of that. So we know this memory that we're trying to deallocate came from our pool. So we can just do our normal thing. We can put it on the free list. Otherwise, it definitely came from the global allocator because there's no other place we've got that can do that. So we just need to deallocate from the global allocator instead, which is the pointer and the original size, which it doesn't really read. But we pass it in anyway to make it the same interface. And unless I'm missing something, that's probably us done. Reallocate doesn't actually change because it just calls through to the other function. So technically we could reallocate by getting a pointer that was in our memory pool. We could allocate it onto the global, and then we could deallocate it from the old pointer from the free list or whatever, or from our memory pool. So this could flip-flop between the two. So that's all good, I think. All we need to do now is try it out. So let's get rid of that. We've got a lot of comments going on in here now. We've got the original Lua new state, we've got our global allocator, and we've got our arena allocator. So let's go with the arena allocator back to what we were. We'll give it as, and we've got our memory. So let's just check this still works with 20 kilobytes. It did before. Looks like it's still working. Remember, we're doing the user values here, but it doesn't actually print anything. Actually, if I put the printouts back in, this draw in on our sprite, remember, just like did a printout of where the sprite was. I think this ran out of memory before. Let's try it. User values. So there you go. We're printing the sprite. And we continue. So it hasn't crashed. So let's just try reducing. Let's try reducing the amount of memory we give it. Where is it? Is it all the way up here? Have I gone to the? I've gone to the old one, have I? Where am I? It's because I've kept all these versions of this. Oh no, there it is. It's, wait for it. I've gone totally the wrong way. There it is. There we are. Let's try reducing the amount of memory we give it. So I think Lua needed about a kilobyte of memory at the start just for something. Let's just give it 3 kilobytes. I think it crashed with 5 kilobytes. Let's try that. And that's all working fine. So it looks to me like we've now officially got, I'm now going to say it, a working arena allocator, which we can allocate a memory pool, a big or as small as we want. In this case, it's got to fit on the stack because that's where we put it, the C stack, not the Lua stack. And if it runs out of memory, it will fall back to the global allocator, which we can put that there. So rather than asserts when out of memory, falls back to global allocator when out of memory, which is pretty cool. So, and I think that is us done for that one. So if you followed along from all the other ones, now you've got a working arena allocator. And this is probably something I would use in production code now, because I can now, even if I give it the tiniest amount of memory, it's still going to work, which is really what we want. Still working with 1 kilobyte of memory. The more we give it, the better it's going to work. I can give it 10K now. That was definitely one of the ones that it would run out on. Yep, still working. Let's just put a debug breakpoint in the global deallocate and allocate and see if it's actually hitting those. Are we hitting them? Whoops, hitting them there and there. There we go. So yeah, so the global allocator was called in this case because we had run out of memory. So that is all good. We've now got a really good working local allocator with a fallback to global memory. Definitely you could use something like this in your own code. You could parameterize a lot more of this stuff in here, like whether you want this 64-byte block size, or whether you want 8-byte alignment, that kind of thing. You could have another arena allocator that had its own little allocation of memory, like the pool could come off the heap, so you could allocate large amounts like that instead of putting it on the stack. But as it stands here, this is I think this is a pretty good allocator, and we already saw in previous video that it got us better performance than the current Lua allocator, so I'm very happy with it. So I think we'll leave memory allocators there for now, and next time we might look at something totally new that we've not done in Lua before. So I'll catch you for that one.